For this question, we will use three equations as our strategy to run through the whole problems. The first equation is about the B field induced by the solenoid, and the second equation is about the B field induced by a ring with current, and the third question is about the EMF induced by the changing B field flux. So first I calculate the magnetic field induced by the solenoid by using the first equation. The question given us the changing current, so we can just use the first equation, and we got the U0 times N divided by D times P minus KT, and that's the magnetic field induced by the solenoid. Then we can calculate the magnetic field induced by the ring. And because the magnetic field is induced by the solenoid, in other words, there's no magnetic field outside the solenoid, so the total flux will be B1 times pi R1 squared. And we can see the total flux is changing and is decreasing by the time. As we can see, the whole equation is times the P minus KT. So at the beginning, the total flux is at the maximum and is decreasing as the time went through. So we can get the change of the total flux. Then we can use the change in flux to find the EMF induced by the whole ring. And we also know the current resistance of the ring, and we can get the current I2 of that ring. It can calculate by the EMF divided by R, which is given by the question. After that, we can use the second equation in the strategy part to find out the total B field induced by the ring. And that's all about the first question.
For the part B for this question, at the beginning, we already know the EMF from the part A, which is U0 times N over D times K times pi and times R1 squared. And also from the EMF, we can get the induced current in the ring by using EMF over the R, which is U0 times N over D times K times pi and times R1 squared over R, which the capital R here is resistance for the ring. And then, as we know, according to the equation given by the question, I1 is P over P minus K times T. In this case, which means as the time increases, the current was decreasing, which means the magnetic field in the solenoid was decreasing. So as we know, the magnetic field induced by the induced current in the ring will be in the same direction as the magnetic field by the solenoid. And then we can easily figure out the current in the ring will be the same direction as the current in the solenoid.